Determined to defrost this track. Now this actually has just started to defrost on the surface where we've left this, we've froze the sand, there's no salt added in it already. We've left it out at room temperature for a while and the surface has started to defrost, so the surface is actually slightly wet now. I suppose you could possibly get the same effect by putting a little bit of water on the track. I'm going to add salt to make enough salt to combine with water to make the concentration 10% by weight. That's 16 grams of salt on this. That's equivalent to about 3 kilos of salt per square meter on a normal track. Quite a lot of salt, in other words, as you will see as I do this. Don't forget, if it does dissolve into the water, 10% salt gives you protection down to -6. The problem there, of course, is if you do manage to defrost your track in the morning, you'll be putting water on it and you'll wash all the salt out ready for the next day when it will freeze again. As you can see, plenty of salt on there, an awful lot of salt. Not sure what salt costs actually. Can you just check the price of salt per tonne? I think it's about 110, 120 pounds a tonne. That's equivalent to putting about 10 tonnes on an entire track, I think. So quite a big outlay. Now, I'm not going to try and break it up this time. I'm going to try and simulate repeated compaction with the tractor driving over it, over and over and over again. And see if we can get enough movement and vibration through the sand Bear in mind, each time I do this, that's equivalent to the tractor going over the track once. So this would be an awful lot of tractor passage. Actually hitting the sand quite hard now. I think it's fair to say that doesn't really work very well. It is softening the surface, but as I say, each time, if you think that every time I've covered the entire pot, that's equivalent to one tractor press. Let's just try harrowing that surface now. Okay, same again. Okay, that suggests it might just be better. Again, it's a bit counterintuitive, as they say, but it might just be better if your track is frozen to drive over it repeatedly with the tractor before you harrow it. That way you avoid, if you can sort of break up the ice in the surface before you harrow it, you won't get those big lumps that are then virtually impossible to break up with the harrow because they just slide between the spikes of the harrow. And add a lot of salt. What we need to do to test this theory properly is to actually do this in a cold atmosphere, because the problem with this is as you start to work on the sand, it's the air at room temperature starts to defrost the sand a lot quicker than would happen in real life where the air temperature is still low. So I think it's very difficult to get a good simulation. So what we'll do, we'll either do this on a frosty day outside, or I'll actually do it in a cold store. Luckily there's one nearby, and we can see if we get the same effect. If we do, then that might just be a way of getting your frozen track ready for a day's racing. So, as I've said several times before, stopping it freezing in the first place is always going to be a better bet. Thank you.